startup, build a blockchain application, but then you're like, well, I don't actually know what the blockchain is. So hopefully I'm going to like introduce everybody from, if you haven't even ever heard of the blockchain, to like at least knowing how to build a basic application on the blockchain, and then you can do your $1 million ICO, and then you can just give me a little kickback for thanking me. Cool. Just before we get started, I'm just curious, who here has ever bought or interacted with a Bitcoin? Okay, we got about 15 people. How about Ethereum? Anybody? We only got about 5 people. Awesome. And how many people here have actually built a blockchain application? Well, Luke should raise his hand. So, okay, this is awesome. So this is good. So there's only 2 of us here that have actually built and deployed real blockchain applications. So cool. So I think everybody's going to be in for a bit of a treat. So just really quick, 30 seconds about me. I run a little blockchain startup here in Thailand called Loom Network. We're hiring. We're looking for really good software developers, as everybody else is in town. I always plug it. I've been a Go developer for the last 5 years, but I do like Python for my data science stuff. And one little fun fact about me is if you get me really drunk, I can only speak Thai. So you just have to keep that in mind for later tonight. Cool. So let's get started. What is a blockchain? I mean, blockchain is really nothing more than a distributed ledger. So like if you took accounting 101 class in school, like a blockchain is nothing but a bunch of transactions between parties. Like I sent Luke $5, Luke sent me $6, I sent this guy $10, he sent this guy $12, right? That's literally all the blockchain is. The blockchain is basically this giant implementation that's running on different computers. So basically what's happening is these blocks are getting distributed on every single node in the network. And there's people called miners that are actually doing mathematical computations to make sure that this blockchain is secure. And it's really complicated, and we're not going to actually get into the actual deeps of like how a blockchain works, because we're going to really be kind of very focused in the next half an hour about like building our first smart contract. Cool. So one of the really interesting things that's actually starting to happen on the blockchain is that you can start building applications on the blockchain. It was kind of like when the web came out, right? Like we had little HTML pages and it was really cool, but it really started to blow up when we could have applications, when we had our Amazons, when we had our Googles, these kinds of things. And this is starting to happen on the blockchain right now, is that we're actually able to build full-scale applications. Well, not truly full-scale applications, and we'll kind of delve into why. But we can start to build programmable applications on the blockchain, more than just sending money between 2 different people. So just to give everybody a little bit of background about the different blockchains that already exist. So the number one is Bitcoin. I assume, how many people here have actually heard of Bitcoin at least? I hope everybody in this room has heard of Bitcoin at this point, even if it's just on the financial news about why it keeps raising in price, right? So Bitcoin is kind of the granddaddy of all the cryptocurrencies. It was made about 10 years ago by this anonymous hacker who calls himself Satoshi. And basically he's kind of an anarchist that wanted to make this new currency for the entire world. If you take 2 things away about Bitcoin, you can think of it as digital gold and a payment mechanism, although a very slow and very inefficient payment mechanism. We're not going to talk at all about Bitcoin because I think Bitcoin is the past, despite what the prices say. I really think the future is going to be on Ethereum. So Ethereum is really the first blockchain that came out that had programmable smart contracts. You could actually build new applications on the blockchain. It was more than just sending payments between each other. We can now send payments to programs, and those programs could actually interact with those payments. So I really feel like this is the platform, if you're going to build applications, this is probably the platform you're going to build them on top of. So to step back, the applications on the blockchain are called smart contracts. And if we think about a contract in real life, so for example, if I buy insurance, right? I buy insurance for my house. I have a contract with the insurance company that if my house burns, they'll give me a specific amount of money. And that's regulated by a very specific jurisdiction. If I buy the insurance in Thailand, it's in Thailand, or if I buy it in America, it's from there, right? But what if we could make contracts that are digitally enforced? We don't need a court, we don't need contracts with people. We actually have a piece of code that binds the two of us together, and we agree that this piece of code defines the contract between us. So for example, one of our friends built this application called Friends in Debt. So let's say that we're going out and having a movie, and I owe my friend $10. I can put an IOU for $10, and then later on, he could owe me $20 for something. And I could actually send real money, Ethereum, Ether, to these contracts, and it could actually pay out the person. And we could even store money in there as kind of a buffer. So you can actually have these contracts that there's no arbiter, there's no third party. It's 100% code that's actually defining this, right? So no longer do we have to trust third parties. So like traditionally with payments, we had things like PayPal. And if PayPal or your bank froze your bank account, there's nothing you can do. But with the blockchain, nobody can control it. So you don't have to worry about another third-party person actually taking your money or freezing any of your accounts. Now, the flip side is, if you heard yesterday, there was a giant hack, and somebody wrote some bad code, and the code allowed them to destroy contracts. So somebody destroyed $300 million worth of money because the code allowed them to do it. And there was no way to rectify it because the code did it, and that's it. So security is going to be like one of the big things that's going to come up here and again on the blockchain. So when we wrote traditional applications, right, we would build a front end, we'd write like, you know, a mobile app, or we'd write an HTML page, and then we'd have an API to like a back end with a database or something like this, right? Well, with blockchain applications, a bit different. So you write these smart contracts, and you deploy the smart contracts into Ethereum. But then you can write HTML-based applications that actually talk to the blockchain. So there's basically a plugin to your browser called MetaMask. And MetaMask actually lets you do cryptographic private encryption and send messages to smart contracts that are actually running on the blockchain. And we're actually going to walk through like what the code looks like for a smart contract, what the HTML would look like to interact with it, and how the steps are to deploy it. So what's kind of interesting is because we have a giant ledger, we can see every transaction that's ever happened between a smart contract. So if we took our example earlier of our friends in debt, we can actually go online to this website called Etherscan, and I could see every transaction that ever happened between that contract. And if we had a dispute, we can just look at the transaction history, we can actually see exactly what happened. Now, the upside and the downside is anybody else in the world can also see these transactions. So it actually creates a lot of transparency. For example, our team is actually doing this project with the Dutch government to track logistics of items transferring between countries. But then you can't cheat the system, which sometimes can be bad, as sometimes you might want to fudge things or you might want to change it, and if it's on the blockchain, you can't actually do that. So now we're going to start getting a little bit deeper. So like, I assume most people here are Python developers? How many people are Python? Only like 4 people at the Python meetup. All right, that's cool. JavaScript? A lot of people raise their hand. One guy, he's a little bit embarrassed that he has raised his hand. He's like, it's okay, we're not gonna hate you for that. That's cool. So, for whatever wisdom, they created their own programming language to build smart contracts. It's a great programming language. It's probably about as good as Fortran 65. If any, I don't know, that reference might be really bad at this point. We'll say maybe JavaScript 1.0 or PHP for younger people in the audience. If it's pretty awful programming language, it's made by some people that didn't really understand, but it does what it needs to do, and we're going to dig in. So I'm going to zoom in. So we're not going to go in deep right this second, but basically I wanted to show you that your entire contract is usually maybe only 100 or 200 lines of code. Because usually you're just defining interfaces between two people. You're just defining like a pathway of money or value between two people. So there's a bunch of tools that don't show up really well on this screen. What's kind of interesting is when you compile these smart contracts, they have API signatures. So when people want to interact with your smart contract, they actually have a function signature. So this is the smart contract that we're going to do today. We're actually going to build a voting application. But it has very specific functions like, I want to vote for a candidate, I want to get the list of candidates, I want to get how many people have voted for a candidate. And there's a strong contract between you and the there's a strong ADI between you and the contract. So you can't accidentally make incorrect calls into the contract. And so this is actually a picture of EtherWallet. As once you've built these contracts, you have to actually deploy them and pay money to deploy them onto the Ethereum network. And that is enough of just like talking about it. I wanted to give kind of like a little bit of background. And now I want to actually dig into code, which will always blow up in my face in front of an audience. So we'll just go with it. So we're going to build this, we're going to show off this little voting application. Let me pull that here. I'm going to pull up we have this little voting application. And the voting application allows us to vote for different candidates. So one of the future applications you could see in Ethereum or in the blockchain would be actually doing elections. You look at Estonia actually does digital-based elections. And maybe as this technology gets better, you could actually see a future where other countries might actually do digital-based elections. So let's kind of dig into this kind of very typical HTML JavaScript application. So the first thing we need to do when we're actually going to build an Ethereum application is we don't want to test on the main Ethereum network because it will be quite slow and we'll have to pay a lot of money. So we can set up a small test network on our local machine. Can you see this? I'm going to raise the font here. Yeah. So we can start a test network on our machine with this program called TestRPC. And TestRPC allows us to build a full blockchain in memory on our local computer. So that way we can deploy smart contracts and we can actually test out our smart contracts because you can't just run them like normal code. They actually need to be run on a blockchain. Because like when you interact with them, you're actually sending transactions, you're sending block transactions and they have to get signed and approved by a blockchain. So next, we're going to kind of dig into like what the contract code would look like. And we're going to like walk through what a Solidity contract actually, what a Solidity contract looks like. So what's kind of really interesting at first is at the very top, we actually tell it what version of the compiler we're going to run. So there's like many increments of the compiler, and there might be small idiosyncrasies between them. And you want to be stuck to a very specific version of the compiler because you're testing this and you want to make sure that your security works. So you don't want to just randomly be changing compiler versions, right? The next thing is that for each contract we're going to define, we create, it's almost like a class, you can think of it. You create this contract class. In our case, we're doing votes. And we're going to keep a mapping of all the votes that we have received. So we're just going to map an ID of a candidate to the number of votes that candidate has gotten. And we'll have a list of what candidates are going to be in our contract. And we have just a couple methods, right? We have a method that allows people to ask how many votes a specific candidate has gotten. We have a method that allows you to vote for a candidate. and a method that just says, is this a valid candidate? Is this somebody that's actually on the ballot? So you could test it. So what would happen is, what I was showing before, if we bring up, is normally what we could do is we could do a couple things. Now that we have the contract, we could redeploy the contract using Ethereum wallet. Or we can just write a piece of code in JavaScript or in Python that actually just manually deploys this contract onto the network for us. So we're going to just show what it looks like to run and deploy a piece of code that's going to deploy this onto the network for us. So hopefully everybody can read this. So I wrote this originally in JavaScript because the Python 2, there's the Ethereum on Python has some issues between Python 2 and Python 3. But anyways, you get the same idea. So there's a bunch of really good libraries called Web3. And basically anything you're doing, you're interacting with Ethereum is you're using the Web3 interface, both in Node or if you're writing an HTML-based application. And what happens is first you have to compile the code because that's just source code. So you're compiling the source code into bytecode that's actually going to be run on the Ethereum virtual machine. And also you need the contract. We were talking before that each contract has, well, they call it an ABI, but you could think of it as an interface or a function definitions of your contract. And basically what we need to do is we're going to actually deploy this contract onto the network. And we can even instantiate the contract. And what's kind of interesting is the constructor to the contract is what's deploying it onto the network in this case. So we're going to say that we're going to have a new voting contract, and there's 3 candidates that we're allowed to vote for: Rama, Nick, and Jose. And after some period of time, from JavaScript, we can actually do votes. We can vote here just from our Node.js application. We can ask for the number of votes, or we can even vote for specific candidates. And what we're going to show is we can either do this from an application like in Node or in Python. We can interact directly with the blockchain, or we can actually build a web UI that does the same thing. The first thing we're going to do is we're going to deploy our contract onto the blockchain. So we're just going to run that same script, and hopefully all things going well. Okay, cool. It deployed our contract onto the blockchain. It voted for Rama 4 times, and none of the other people. So every time you deploy a contract onto Ethereum, you're going to get an address. You're going to get this address, which is, you can think of it as the URL of where the contract lives. Because it's a network of a whole bunch of contracts, you need to know where your contract lives on the network. So what we're going to do is we're just going to copy this contract address, and we have some JavaScript that runs in the browser. We can go through it here. Once again, we have the same code that we were doing in Node.js, but this is actually going to be browser JavaScript that we can connect. We can connect to this voting contract, and it's at this address that we just deployed it to. And we can then do voting for candidates. So we can use all the APIs as though it's a real class, it's a real JavaScript class. But it's actually not calling something locally, right? It's actually going to sign a private message and send it to the blockchain. So we'll kind of walk through and show how that looks. So yeah, and we just have a single HTML page in this example that's really just very plain, that just allows us to visualize. So if we come back here, we don't see any votes yet. That's because we're not actually connected to our fake test network. So right now, so you see this thing up here in the top, it's called MetaMask. And this is the plugin that allows you to interact with the Ethereum network. Because your normal Chrome browser can't just interact directly with the Ethereum network. So what we're going to do is we're going to come onto my local test network, and we're going to add a new account. Because we have to add a new account. An account is just a private key. Cool. And if we refresh this, it's not friendly. You should be able to invoke for Rama. And of course, the demo gods are not going to be with me on this one. 1 second. So obviously I copied something wrong here. So we're going to go and look at why. Now I get to show why this is still quite complicated. Oh, because I'm referencing stuff on the internet. That would be why, and I don't have internet. 1 second, sorry. I'll just use my iPhone here. I'm pretty sure I tried this before. This is why we never do anything that requires internet in a demo. All right, cool. Awesome. So you can see, like, on the command line, we have voted 4 times for Rama, and that's what we expected. So what we can do is we can, like, vote for Jose. We can vote for him a couple times. We can vote for Nick. Cool. And now we can also write another program, whether it be in Node.js or Python, that could actually just read that data. So we have this other contract. So let's say that now that you've written this, you have another person that wants to, like, read these votes out, right? So we have just a few lines of code to be able to interact with the contract already on the chain. So basically what we do is we just recompile the code, we create our contract, and we take in what the contract address is, and we can actually just read what all the votes are for each of the candidates. So if we did everything correctly here, we can have a command line program that also interacts and sees that the same votes that we have on the HTML. So just to kind of circle back, I'm trying to show here, is this is all running on my own virtual instance of the Ethereum network. Normally this would take like 30 seconds to a minute because you'd have to do these transactions. The transactions would actually have to get approved by miners. So like when you run it like on the main network, it's a good bit slower. Yeah, you want to? Yeah, so it would be a good bit slower. So this is kind of like a whirlwind overview of like what it looks like to build a sample application, deploy it, and actually run it both from a standalone application and a GUI. Nice. So, where's the Python? Why would I, if I'm a Python developer, if I'm an application developer, how does this fit into me? So, there's kind of be 2 kinds of developers that are going to be in this ecosystem. There's some people that are writing these contracts that are like doing very specific things like managing debt between 2 people or doing logistics calculations. But then there's also a lot of applications that are going to be built in like traditional things like Python or Node, where you're going to read from the blockchain. So one of my failed startups earlier this year was actually storing SSH keys on the blockchain. So you would write all your SSH keys, and then you would just have a program that would read the SSH keys from the blockchain. So you can envision that there's like a huge ecosystem where you could even build payment applications that are just interacting with the blockchain. They're not necessarily building their own kind of smart contracts. I gave a lot, and I wanted to show the raw pieces. I wanted to show kind of without any framework, without any tools, what it actually looks like. If you're going to go home tonight and you just want to build a really quick, stupid, smart application, you want to build a dice game or something, just go grab the Truffle framework. It's really simple, and it has like a very step-by-step guide of how to like build your framework. All this stuff where I have all the testing, setting up the test RPC, it does all this for you. It even has an integrated testing library. So if you don't know a lot about using Ethereum, you can just write JavaScript to test your applications. And so Luke and I, and my partner here, we've done a lot of stuff on the blockchain, and I know most people here are very junior. But I wanted to go ahead and tell about a couple of the major pitfalls that we've run into. So if you actually start getting into this and you start running into issues, you'll kind of have at least some ideas. One of the biggest limitations right now is actually the size of the contracts you can build. So like, a lot of times you'll be building contracts on your local machine and you start to make them, they're quite large and they run quite well. And maybe even you run on one of the test networks and they run fine. But you get into the main network and you can never deploy it because no one will accept it because it's too large. So like as you're building your application, you need to make sure that you're testing it on the main network so that way you can validate that it's actually going to run there. The other thing is, it's still quite expensive to run applications that store a lot of data. So if you, for example, you wanted to store, like I was, storing SSH keys, or you wanted to store like textual data in a smart contract, it's going to cost you a lot of money. It could cost you $1, $2 per transaction. It starts to add up. So things that you want to store in the blockchain are things are like hashes or just identifiers, so you can track individual items, but not the actual full representation of that item. The other kind of pitfalls we run into was Solidity is a really rough programming environment. There's a lot of things like you can't do string concatenation. You have to have a library to do string concatenation. So there's a lot of really good tools online. One of them is like etfiddle. There's things like Remix. There's a lot of really good tools. If you come grab me, I'll kind of talk about some of those. So I usually like to open it up for some questions because I tend to just throw a lot of things out there to give people a taste, and I want to open it up for a few questions here.
You kind of touched on it at the very last part of the pitfall, but I mean, algorithms without data have marginal value. How do you actually get at data in order to be able to build stuff up?
That's a great question. So there are certainly a lot of limitations, and some of these are going to be addressed with sidechains. But if you needed to build an application today, let's say that you're doing our logistics example.
Can we try the example that you had earlier with the voting? So how does a person, for example, prove they are who they are, say they are, and that they've only voted once?
Oh, that's easy. That's you can certainly do. So with the voting example, everybody has a private key. And what we would do is, like, say what would happen is the government of a country, like Estonia, issues a private key to every citizen.
It's not private if somebody else is issuing it.
Well, the government is issuing it. I mean, the government is, I'm sure there's a...
Okay, all right.
Okay, anyways, there's a private key per citizen that's linked, and maybe the citizen is generating it, but each citizen has their own private key, right? And each private key can only vote once in the contract. And the contract doesn't store names, it's just the hashes or an identifier, like you could say a social security number or an identification number of each of the candidates, right? And what could happen is you could store the hash of the private key, which is the public address of some user, to their votes. And that is something that is definitely feasible in today's environment.
So then extend it onto the example you have with supply chain, where you've got bigger amounts of data you're trying to do.
Right, so like if you have supply chain, so the example that I'm thinking of is we want to track goods that are shipping between the Netherlands and Germany. And we want to make sure that the correct duties and customs are, as they go out of the EU, the duties and the customs are actually levied on the goods that said that they were coming through, right? So in a case like this, each kind of item, you would have a hash or an identification, right? And you would have some kind of central database that is not on the blockchain that actually represents, this is a carton of milk, this is an electronic board. But there's just an identifier that marks that.
And that thing's got to be trusted too, right?
And vision would be that a regional province, let's say that Bangkok government or the Thailand government has a registry of all the houses in Thailand. And I could put so many million bahts into the contract, and then I become the owner of that in the blockchain, right? And the contract would enforce it on the owner. Now, if it's a physical item, you would still need support from the local government to actually enforce those rules, right?
But my question is, if you don't want to put all the data, how is all the data represented?
So this is back to his question. So basically, if you have larger sets of data, so there's other technologies like IPFS, which is interplanetary file system, or Swarm, and you can put these on distributed file systems. And what you would do is you would take the larger data sets and you do cryptographic hashes of them. And then you would write the hashes to the blockchain to validate that the data in this other place is the data that you say it is.
Or at least that hasn't changed.
Right, it hasn't changed.
With IPFS, it's content addressable. So you put the hash into the blockchain and you ask IPFS, please give me this piece of content.
Yeah.
It only gives you the piece of content that corresponds to that hash. The hash is derived exactly from the content. You can't go and change something and work it.
So you're saying that blockchain is like an AWS buffer?
Not really. Not really. It's more like a distributed database. It's a very simplistic distributed database with smart contracts, essentially.
That's why it fits in finance so well, is because we've been dealing with ledgers for 500, 600 years, right? With the double-blind accounting and all that kind of fun stuff that's going on. So, accountants for forever know that once you've written a transaction into the ledger, you can't change it. You might disagree that that value was captured correctly, at which point you might create another compensating transaction to deal with it, but you can't change the original one. And that was very much holds true for the blockchain.
Right. So the canonical example here is if you're a stock market, right? A stock market is nothing but a ledger of transactions between individuals. So like if we're selling, a good example of using the blockchain would be like, if we wanted to redo the New York Stock Exchange, we could redo it as a blockchain because all of the participants could trade stock via smart contracts. And it would be the exact same as how the existing stock exchange would work.
How would you do high frequency trading when
Yeah,
doesn't sound?
Oh, so that's a good question.
Different problem.
So I'm just going to touch on this really quickly. But if you look at JP Morgan has a blockchain product called Quorum. And it's a blockchain product between semi-trusted individuals. So like let's say that I have 50 banks and they're in a semi-trusted environment. You can do high-performance blockchains that are quick enough to do stock-like transactions.
As long as you trust the miners that are asserting that blockchain is valid, you don't have to have a shitload of them. The reason Bitcoin is so slow is because there are thousands of them out there trying to agree.
Yeah, it's slower based on how much untrustworthy it is. So like Bitcoin, you don't trust anybody in the world, so it's going to be very slow.
So you mentioned the money, like how does that transaction go and how does that presumably goes towards the miners somehow? How does that work?
Right, so the miners are basically doing a lottery. So the miners are doing these mathematical functions. And every so often they win and they get a new block. And they get a portion of the Bitcoin from that block. And then they can sell those Bitcoins on exchanges or something. And that's how they actually make money. Or they could use this Bitcoin.
You just mentioned Quorum. I'm a little curious. Do you know how Quorum differs from Ripple? Isn't that sort of the
So Quorum is an open source project that can be implemented by multiple parties, where Ripple is like a conglomerate of very specific banks. So you could build your own Ripple with Quorum, essentially.
Well, I already deployed contract and the schema and the
No. So you deploy new contracts.
Better get it right the first time.
Well, yeah, exactly. I mean, it could be very costly if you get it wrong because you could lose a bunch of money if you have a contract that is insecure. Right?
Yeah, there was a contract that was violated a few years ago, and somebody locked up $200 million.
When you redeploy a new contract, will you lose all the data inside the previous one?
No, so that old contract still lives forever, right? So it's possible if you wanted to design something where the new contract could read or interact with the old contract, you could also do that too.
But the ledger gets getting bigger and bigger and bigger and bigger? Is there a point where you're going to break? Because it becomes
This is a great question, that the ledger just keeps getting bigger and bigger. So this is the biggest fight in Bitcoin. So Bitcoin, they've been trying to raise the size of the blocks so they can have more and more transactions. But the larger the blocks, the larger the size of the network. And at a certain point, not enough people can store the entire ledger on a single machine. So like Bitcoin is maybe 50 or 60 gigabytes, and Ethereum is like 300 or 400 gigabytes. So you can still store it on an average-sized laptop. But the security of the chain depends on having many people having copies of this. But what the Ethereum client does is it gets just a fraction of the network. It will download maybe 10 gigs of the network, enough to prove that it's likely secure, but there still needs to be people that have full copies of the network.
Okay, about the data representation. So we need to store big data into somewhere else, like IPFS. So does it mean smart contract can access blockchain or IPFS directly?
No, but you wouldn't necessarily need it to. So most of the time, you would just be you would be returning addresses to the larger portions of data, or you're just going to reference those bigger pieces of data. You're not going to read them from the smart contract.
So what if I need to do that in a smart contract? Would that be possible?
Yeah, that would be impossible.
Okay.
So with the voting, the thing that might work, if you want to actually enforce that a single ID can only vote once, actually doing that in your output code, you write that sort of outside and do a query of the blockchain and do that check before the person votes, or is it sort of inside the contract code itself?
It's in the contract code. So what would happen is I would sign a transaction with my private key that says I'm voting for Bob. And it goes to the smart contract and it would look up and it would probably just have a map. And it would say, Matt's private key already voted for Rob. Oh, I can replace it, and now he voted for Bob. But you would basically, you could just have basically a map inside the memory of the smart contract, and you can update that, but it would be later in time. So then you would, at some point in time, you would cut it off. You can even have code in the smart contract that says, after this date, I'm not going to take any more votes.
But every vote you can listen into the blockchain
As a transaction.
So in that situation, my understanding is that you get charged Ether for, I think of it as the CPU cycles that are used to execute the contract. So as the number of people that have voted starts to grow, doesn't your traversal for that start to increase and your costs start to go up?
Yeah, I mean that's probably pretty small because it would just be a singular map. Maybe you could have a couple of maps. You could break it out by voting region, but that piece of logic is pretty cheap. But if you had to do a lot of complex logic, like say, okay, if this person older than 18, is it like this? If you have like branching logic, then you could get to be more and more expensive.
So you only pay whenever you use the contract, or whenever somebody's using the contract.
Yeah, so you only pay for writes into the network. So reads are completely free from the network. Right, and well, because you can also have an entire copy of the network on your machine, so you can just read your own copy of the network.
So that map you're talking about, is that stored in one transaction, or is that stored across all those transactions?
So it's the end state. So if we come back here.
The state must be one transaction.
So each piece of state is in one transaction, but then there's a, like, what is the final? So if we look here, we have this votes received at the top there. You can't see it very well. We have essentially a map of like candidates to votes. And that's the end state. So each transaction on the blockchain, there will be a single transaction that you voted, I voted, he voted, he voted. But in the smart contract code, it's like you can think of it as a materialized view of all the transactions that have happened up to that point.
So just to clarify, every new block, every time you make a transaction, a certain amount of the data is passed along the transaction, signed by you, and it's stored in the next block on Ethereum. And so the actual bits and pieces of the data are stored across time. You don't actually update a database back in time. It's just stored with the next block. So if you were actually going to read and there's, let's say, 5 million votes, you would have to crawl through time to get all the data for all the 5 million votes, which is going to be very, very slow. But that read speed is not charged. You pay for your own reads. You run your own server, so it's free to read from the blockchain.
And while you're doing, you're skipping over everyone else's transactions happening at the same time as well, right? Like
Yeah.
your vote to be interspersed with the entire universe of other
Yeah,
transactions.
exactly.
Yeah, and you also have like an address, so you can actually just look up. But I mean, performance is not very, very good on the blockchain, no matter what. So.
But an application like voting, if you're talking it takes a minute or so to do a vote, it's not the end of the world.
It can be expensive too.
Well, a vote would maybe be 30 cents to $1. So like maybe 15 baht to 30 baht, something around that line range to do a vote.
But when we are trying to read the latest state of this contract, could we just skip to the last transaction of this?
So that's all transparent to you as both the user of the contract, or if you're writing like a Python application, you connect to your implementation of Ethereum, like you run one on your machine or you run one in the cloud, and that's transparent to you. You don't have to understand that all these transactions come. It's like when you use MySQL, right? MySQL has a transaction log, right? And it's just creating all these transactions, but when you read it, you think that it's just mutable state. But it's really just all these transactions together have been smushed into one point. And from you as a developer standpoint, it looks like it's just the latest version of the state.
Cool. I'm not a developer, or I'm just new to Bitcoin and blockchain, but I read some stuff. And what about Ethereum is that I heard that Ethereum is Turing complete, and at the same time, meaning Turing complete means maximum expressiveness, but it's undecidable. So meaning it's like for when you say Turing complete is about the halting problem, you cannot see if
Right.
it's undecidable. So meaning if it's undecidable, you're not really sure if your code will work or not. So if your code is will not will,
Yeah.
will,
So the thing is it's Turing complete. It's like any other programming language, meaning you can express any constructive logic in it. However, you have the halting problem. So you don't want these contracts to run forever, right? So you give this thing called gas, which is basically payment for CPU cycles. And each opcode in the virtual machine costs so many gas. So let's say that you have tons of branching logic. You could have potential where some transactions will just fail. But you'll get a response and you'll know that your transaction failed. So let's say that I'm voting and I don't send enough gas into the voting. I'll get an error back saying that my vote wasn't tallied and that I need to send more gas. So it's just a mechanism. Anytime you have non-deterministic code, you're gonna have to stop it at some point. Otherwise, you could have an infinite loop accidentally or something like this. That's a good question. Does that mean that everybody can see my vote? No. They would have to know your private to public key matching. And so like when you actually sign the transaction, you don't sign with your ID card, right? You have a private key. And nobody else would know, unless somebody else knew your public address, then nobody else would know who you voted for. And
Does that mean it's subject to share our public address?
right, so in the case of a voting application, yeah, you could generate a new public address or something like that. You would probably want to have a new public address that's specific to the voting, so that way people wouldn't know who you are specifically.
So one of the problems with Bitcoin is that looking at people's patterns of buying and stuff like that, you can kind of work out who people are some of the time. And some of these other blockchains try and avoid that. Is Ethereum one of them, or is it still at the central?
So Ethereum, you can track transactions. Basically what you're saying is that there's some of these blockchains that are totally private, and they try to make it so that people can't follow your transactions, right? I mean, there's ways to get around it. Like you could create your own private keys, you could go through Tumblr services. But yeah, to some extent, if somebody let's say that I sent you money, then I knew your public address. And then I could watch you do other things. But you could send money to an exchange, like you could send it to the local Thai exchange, and it would end up in their wallet, and then you could send it to somebody else, and nobody would be able to track it because you've come to a disintermediary, and then you can hide the transactions like that. But they're not for. That's not like their main idea is with Ethereum to hide where your transactions are going. Cool. I think that's good. One last one.
Is the data stored in the blockchain?
Who's the real owner of the data? Whoa, that's like a metaphorical question there. It's like, wow. Nobody. That's the thing is that nobody owns it. So what you can do is in the contract, you can define somebody who's the owner of a contract, for example. So like you could say that my public key owns the contract, but you don't own the data. You can just control that contract.
So everyone can get use of that.
Yeah. So if you store something, like you accidentally store your earnings report. Not that you could at the moment, but other people could see it, and you wouldn't have any kind of recourse against that.
There are other blockchains that are designed to be private, right? So they're not public ledgers. That they are only accessible by the people that actually have the access rights to get into it. So that's a lot of what like IBM and companies like that are doing. This is a public.
Yeah. And it could be good. So like cases where you're dealing with a government, if you wanted to keep the government on track, having the transparency of being able to see what's going on could actually be quite beneficial. So cool. I think let's wrap it up because that's quite a bit of questions. So.